Hi, this is the last day of your limits notes, and it's about finding limits to infinity. Remember, on Friday is going to be your online limits test. There will definitely be questions from this day's notes, limits to infinity, on your online limits test. So if you have a rational function where the numerator and the denominator are both polynomials, and you're finding the limit as x either approaches positive or negative infinity, and again, this only works for limits as x is approaching positive infinity, what you're going to do is you're going to divide both the numerator and the denominator by the highest exponent of x, and you will have to keep in mind that the limit as x is approaching either positive or negative infinity of 1 over x raised to any power at all equals 0. So it might not be a bad idea to take a quick look on your calculator for a function and say we're going to graph y equals 1 over x. So if I'm going to graph y equals 1 over x, and I look at this graph, as x is approaching positive infinity, your function, your y value, your limit is coming to a y value of 0. As x is approaching negative infinity, your function value, your y value, is approaching a y value of 0. This is true of 1 over x raised to any power. Okay, let me start going through the examples. For example number 1, we're looking for the limit as x is approaching positive infinity. So it's a limits to infinity rule of 6 over x. Now, I could rewrite this example as the limit as x is approaching infinity of the constant 6 times 1 over x. Okay, so the limit of a constant is the constant. That was in yesterday, no, it was probably in 2 days ago notes. If you look at the function y equals 6, y equals 6 is a horizontal line that looks like this. And no matter where you look at this function, say you look at this value of x, and as you approach x from the left and the right, this is only coming to a y value of 6. So any time you're taking the limit of a constant, the answer is that constant. That will be one of the questions on Friday's test. Okay, so if I break this up into separate limits, the limit as x is approaching positive infinity of the constant 6 is the number 6. The limit as x is approaching positive infinity of 1 over x, and I just showed you that graph, and can you look at it yourself on your graphing calculator, is 0. So when you multiply these together, the limit as x is approaching positive infinity or negative infinity, it doesn't make any difference if it's positive or negative infinity, of 6 over x is equal to 0. And we're going to use that to do some of these other questions. Now, when you have a rational function, what you're going to want to do, there's a shortcut on the back. I'll get to the shortcut in a few minutes, but this is more the rules of limits to infinity. Example number 2 is the limit as x is approaching positive infinity. Again, it doesn't make any difference at all if it's positive or negative infinity. Of 8 over x plus 6 divided by 3x minus 1. Now, what's stated up above for the directions is you divide both the numerator and the denominator by the highest power of x you see anywhere in here. So this is an x to the first and x to the first. The highest power of x is x to the first. So I'm going to divide every term in this rational function by x. Limit as x is approaching infinity of 8x divided by x plus 6 over x divided by 3x over x minus 1 over x. Now, there's a couple of situations in here that you want to pay careful attention to. Anytime you have this situation, where you have a constant divided by x to some power, and you're finding a limit to infinity, that becomes a 0. So I'm going to simplify this. I want the limit as x is approaching positive infinity. When I divide 8x divided by x, I just get 8. This stays 6 over x. When I divide 3x over x, I get just the constant 3 minus 1 over x. Now I'm going to take the limit of every piece of this, of every part of this. When you do the limit, you drop out the limit notation. The limit of a constant is the constant. So the limit as x approaches positive and negative infinity of 8. Remember that y equals 8 is a horizontal line at a y value of 8. So any value of x between negative infinity and positive infinity would approach 8 from the left and the right, the y value. So the limit as x is approaching positive infinity of this constant 8 is just the number 8. The limit as x is approaching positive infinity of any constant divided by x is 0. The limit as x is approaching positive or negative infinity of the constant 3 is just the number 3. And the limit as x is approaching anything divided by x to any power limits to infinity is 0. So this simplifies just to be 8/3. So the answer to this, the limit as x is approaching positive or negative infinity of this rational function is 8/3. Now, the other piece that this gives you is if you were graphing this function, and this would be a really good time to pick up your graphing calculator, put this function in, look at this function. This function would also have a horizontal asymptote at y equals 8/3. You would see that on your calculator. Also, the range of this function would be from negative infinity to 8/3, because there would be a horizontal asymptote there, and from 8/3 to positive infinity. So this is another quick way of finding a horizontal asymptote in the range of a polynomial function. Let's look at the next example. Example number 3 is the limit as x is approaching infinity. It doesn't matter if it's positive or negative infinity, of 3x squared plus 2 divided by 4x minus 3. Okay, so first thing we need to do, because this is a limit to infinity, we're going to look at everything in this polynomial function. We're going to divide everything by the highest exponent of x. The highest exponent of x is x squared. So the next step is I'm going to keep my limit notation in there. As x approaches, again, it doesn't matter if it's positive or negative infinity. I'm going to divide everything by the highest exponent of x, so 3x squared divided by x squared plus 2 divided by x squared divided by 4x divided by x squared minus 3 divided by x squared. Dividing everything by the highest exponent of x, simplify everything. So we're going to evaluate the limit as x is approaching infinity. When I divide this, I just get the constant 3 plus, this doesn't reduce, 2 over x squared. In the denominator, this x to the first and this x squared cancel. You'll have an x to the first in the denominator. 4 over x minus 3 over x squared doesn't cancel. Right, so I've divided everything by the highest exponent of x. I've simplified. Now I'm going to apply my limit to infinity rules. This is the rule that you want to keep track of for limits to infinity. If you have any number divided by x raised to any power at all, and finding a limit to either positive or negative infinity, that limit is equal to 0. So I've simplified everything. I'm going to drop out the limit notation. I'm going to apply the limit rules to every piece of this. The limit of the constant 3 is just the number 3. The limit as x is approaching positive or negative infinity of any number divided by x raised to any power is 0. The limit as x is approaching infinity of any number divided by x to any power is 0 minus 0. So we're left now with 3 over 0. So the function would be undefined. Function values when they don't exist are undefined, but the limit does not exist. So limits, you have to say does not exist if it doesn't approach the same y location from both the left and the right. And you can look at this graph on your calculator and look as x is going to positive infinity. If this graph is going to a y value of positive infinity, a y value of positive infinity is not a single y location, so limits to infinity do not exist. The last example on the front of your notes, example number 4, is the limit as x is approaching negative infinity. Again, it doesn't make any difference if it's positive or negative infinity, of 5x minus 6 divided by x squared minus 4. Okay. Divide everything in the polynomial function by the highest exponent of x. In this case, it'll be x squared. So we're going to evaluate the limit as x is approaching negative infinity of 5x divided by x squared minus 6 divided by x squared, dividing everything by the highest exponent of x squared divided by x squared minus 4 divided by x squared. Next thing I'm going to do is simplify each of these fractions. Keep the limit notation in until the very end when you apply it. 5x divided by x squared is 5 over x. 6 over x squared doesn't reduce, 6 over x squared. X squared divided by x squared reduces to be 1. 4 over x squared doesn't reduce. Pay attention to the rule to positive or negative infinity. The limit as x is approaching positive or negative infinity of any number divided by x raised to any power is 0. So now I'm going to do the limit of each piece of this. I'm going to drop out the limit notation. The limit as x is approaching either positive or negative infinity of any number divided by x is 0. The limit to infinity of any number divided by x to any power is 0. The limit of the constant 1, the limit of a constant is the constant, that's 1, minus 0. When you simplify this, you get 0 over 1, so here the limit is 0. So what that means, if this function has a horizontal asymptote at y equals 0, it means that the range of this function is from negative infinity to 0 and from 0 to positive infinity. If you put the function right here into your calculator and you look at the graph of this function and you look as x is approaching positive infinity or negative infinity, it should be clear that the y value is approaching a y value of 0, which is the limit. Now, that's applying the rules to infinity, but what's kind of neat about this is there's a shortcut if you learn it. I would also suggest always looking at the graph of the function to help you with limits. Okay, so example 5 on the back is the limit as x is approaching positive infinity of 8 minus x divided by x squared plus 3x minus 1. Example, this was example 5. Example number 6 on the back is the limit as x is approaching negative infinity. It doesn't matter if it's positive infinity or negative infinity, makes no difference at all, of 3 minus 5x squared divided by 4x squared plus x minus 3. And then the last example on the back example number 7, probably not on the back of yours, you're probably printing this onto 2 separate sheets of paper, is the limit as x is approaching either positive or negative infinity, doesn't make any difference. And this one is 7x raised to the 4th plus 1 divided by x squared minus 2. Okay, now, here's my notes from the back. I really hope you guys are opening up my notes that are all filled in. I have lots of extra writing on mine to help you. Hopefully that's helpful. But on the top, it says shortcuts for limits to positive or negative infinity. And this is a really easy way to evaluate these limits, but you can always support it by looking at your graph too. Okay, the first one says if the degree of the numerator is smaller, less than the degree of the denominator, that means if the highest exponent is the bottom, the limit is 0. So let's look at these. Here is a situation where it's an x to the first in the numerator and x squared in the denominator. The higher exponent is in the denominator. When this occurs and you're finding the limit to infinity, it's always equal to 0. There would be a horizontal asymptote at y equals 0 on this function. The next thing says, number 2, up at the top, if the degree of the numerator and the degree of the denominator are exactly the same, the limit of that function as it's approaching positive or negative infinity is the coefficient of the highest exponent in the numerator and the denominator. So for this next example, the highest exponent in the numerator is an x squared. The highest exponent in the denominator is an x squared. The degree of the numerator and the degree of the denominator are exactly the same, so the limit as x is approaching positive or negative infinity is the coefficient of these two terms. So it would be negative 5 over 4. This particular function would have a horizontal asymptote at y equals negative 5/4. It also gives you your range. The range of this function would be from negative infinity to a y value of negative 5/4, not included, and from negative 5/4 to positive infinity. Now, example number 3, or rule number 3 for shortcuts for rule to infinity, says that if the higher exponent is on the top, for this last example, the degree of the numerator is an x to the 4th. The degree of the denominator, it's always your highest exponent, is x squared. In this last example, the higher exponent or the degree of the numerator is bigger than the degree of the denominator. When this happens, the limit does not exist. Okay, so I hope that you guys understood this. This is the last day of limits notes. Next week we're going to start derivatives. On Friday of this week you have your limits test. I would really, really strongly recommend that you go through all of your notes from limits day 3 very carefully. Maybe make a really good test review sheet, and these limits to infinity, that's what most of the test is going to be about. I hope that you're all doing well, and we will be back together again soon.